In this video, I'm going to show you how to use this plunger wave simulation. You were given a worksheet that goes with it that has this table on it. It gives you a plunger speed, a plunger size that you have to plug in, and it wants you to find the amplitude, the wavelength, and the frequency for the wave that results. Now in this plunger lab, you'll see that the speed control is up here. We're going to keep it at slow for this example. The size is right here. We're going to keep it at small for this example. So on your chart, we're going through this first row right here. So we're going to go ahead and start the plunger. The plunger is going to go up and down, starting the wave. Now, once the wave goes by, we can see it's going through this grid that will help us to take measurement. The resting position, if we stop the plunger, it takes a second for it to stop, but you'll see that the resting position is right here at this line, and on our grid it's at 0. And when we start it again, you'll see that the amplitude of the wave is how far away it goes from that resting position. So right here, if you have a hard time seeing these numbers, you can click the magnifying glass and you can see that there's a 0, the 1 would be right here, and then the 2 is labeled. But you can see that the crest of the wave is coming up here to the 1, and the trough of the wave is coming down here to the -1, which means both the crest and the trough are 1 centimeter away from that resting position. So when we go back to our chart, the amplitude is 1 centimeter away from that resting position, an amplitude of 1 centimeter. For the wavelength, you can click this step button here, and it stops the wave and gives you a line, and it shows there's a red dot on the crest and a red dot on the crest. There's a yellow dot on the trough and the yellow dot on the trough. And the measurement of the wavelength is either from crest to crest or trough to trough. So we're going to click step until we get to a point where there's either 2 crests or 2 troughs on the grid, like so. And then we will count how many centimeters it is between the crests, or if you had the troughs. If we start here at 0, we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 centimeters. Or if you were astute, you might notice that the numbers are labeled down here, and it goes to 16 right here, which means 15 would have been right here. So 15 centimeters is the size of our wavelength. Go ahead and put 15 in the wavelength right there. The frequency is a little bit more complicated. You have to use the timer up here. Now, if you reset the timer while it's on step, then the timer should stop. If your simulation is on step and your timer keeps going when you say reset timer, refresh your page, because that's a glitch that sometimes happens with this simulation. There's also another glitch that happens with this simulation, which is that when you click step, it should just move 1 step forward. Oftentimes, if you click step again, it automatically starts playing it again. If that happens, you need to start stepping over, because if it starts playing while you're trying to count the wavelength, you won't get the correct wavelength. Click step again, it starts going, and you want to make sure that you step it enough so that the red dot is somewhere on the grid. Now, if you have the red dot at the beginning, reset the timer, it's always going to start playing on the second step, like that. So start it somewhere after the second centimeter. So maybe right here would be a good spot. If you look down at our numbers, it's right before the 3. So we can start it here. We'll go ahead and reset the timer to 0. Now frequency is, of course, the number of waves that go by in 1 second. So if we click the step, it gives us 0.1 second. So we've got to get all the way up to 1. So we click it once, 2, 3, 4, 5, 6, 7, 8, 9, 10 times, gives us 1 second. Now remember, it's the red dot started just before the 3 here. Let's count how far it went in 1 second. We've got 1, 2, 3, 4, 5, 6 centimeters in 1 second. Now, 6 centimeters is not an entire wave, and frequency is in waves per second. It's not the whole 15 centimeters of the wave went through. We had 6 out of the 15 centimeters go through. So 6 divided by 15, or 6/15, is the number of waves that went by in 1 second. Now, if you know fractions, you know if you've got a 1 on the bottom, that's always the same thing as just writing the number on top. So we can get rid of the 1 here. But if we're going to do the 16 over 15, if you go back to your simulation, there is a calculator right here that you can click on, and we can click 6 divided by 15 equals 0.4. So when we come here, 0.4 is the frequency of that wave because 0.4 waves went by per second. So now we can see that the amplitude is 1, the wavelength is 15 centimeters, and the frequency is 0.4 waves per second.